ठीक है टेस्ट कर लीजिए एक बार
नहीं लमसम 120 कल भी था
गुड मॉर्निंग एवरीवन good morning all the participants. So we are waiting for our honorable speaker to join. So once he'll come, then we'll start the session in another 5 minutes maybe.
But it is, I think I'm making some mistake somewhere, correct? I leave again. Yeah, I mean now, yes.
Sir, good morning. Partho here, sir.
Yeah, good morning. Yes, from my side.
How are you, sir?
Fine, thank you. How are you?
I'm fine. So formally, I welcome Professor Mustafizur Rahman. He is, I need not to give a special introduction for Professor Rahman. He is known among the community across the globe, particularly in the area of micromachining and micromanufacturing. And the day we started to elevate our institute to the level of an institute of advanced manufacturing, Professor Rahman has, volunteered to mentor us with every advice, every support. Sir, we are truly grateful to you, sir. So I believe the
Thank you.
participants will be enlightened with his lecture to a new direction of technology, which we must adopt in future to pursue the sustainable manufacturing. Sir, I will request Himanshu to give a brief introduction.
Good morning, sir.
Good morning.
Good morning, all the attendees and panelists. So myself, Dr. Himanshu Khandelwal, I'm assistant professor here, Department of Foundry Technology, and apart from that, like I would like to welcome you and all the panelists on behalf of our organization and this futuristic and advanced manufacturing forum of India. So sir is also one of the mentor for us. So yeah, so before moving to the session, I would like to take this opportunity to briefly introduce sir. So sir, Dr. Mustafur Rahman sir, uh, his research interest includes in ultra precision machining, micro machining, design and development of machine tools, and high speed machining, hybrid machining, ductile mold machining of brittle material, and also development of machine tools and device for micro and nano machining. So Rahman sir had been in the Department of Mechanical Engineering at the National University of Singapore from 1982 to 2018, and currently he is the managing director of Micro Tools Private Limited, so which produces machine tools, precision and ultra precision machining. So he has received many awards. Some of the important ones are William Johnson Gold Medal for Lifetime Achievement in Material Processing Research and Teaching in 2009. The Leading Edge Manufacturing Achievement Award from the JSMB in 2005, and IES Prestigious Engineering Achievement Award in 2003. AM Strickland Prize for IBECI in 2009. He has authored more than 500 journal and conference paper. It's really proud for us, sir. He is the editorial board for 11 international journals. It's my privilege to welcome sir, and sir, now it's I over the session to you.
Okay, thank you. Thank you for your kind introduction. From Singapore, it is good afternoon to everybody, but in India, you receive it in the good morning.
Yes.
Okay. So thank you all for coming to attend. And I will try to justify my presentation, but I'll try my best to do the thing. Let me share the screen with you. Okay. I was really surprised when you got the topic of advanced machining techniques in remanufacturing. I thought about it, but I'm really surprised that your institute has proposed such a talk, and it came to me to do this. So I feel it is very, I was in a rush to prepare myself because I'm talking all the time about advanced machining processes. But your institute, the director started thinking it to apply in remanufacturing. That gave me a moral boost that, oh yes, even advanced machining processes will be used in remanufacturing. Then I started thinking about it, and really it was a timely topic, and I feel that this is the way it should go, because advanced machining is more important for remanufacturing than any other machining processes. Let me go to the topic itself. First question is, why remanufacturing? I'm sure all of you know that remanufacturing is necessary because the way we are misusing or using our resources like energy, water, and food and materials, everything is getting depleted to improve our quality of life and to improve our productivity. So, but the energy spending is in one line, which is getting really more and more energy resources are getting depleted. So if this continued, I don't know how many COVIDs will become, how many natural disasters will come. So it is our responsibility to change this trend. As you see, this trend needs to be changed in this direction. I didn't say it should be moving in a steady direction. I should say reverse it in such a way that we will be using less and less energy. That means it is no more circular economy. It should be spiral economy moving upward. Okay. And if we do not do that, what will happen? What we see was what was this environment or universe in 1990, maybe in 2000, something, it will be like this, and next century it will be just desert. We cannot afford to do that. We'll have to think sustainably. We need to remain sustainable. And so we'll have to continue with sustainable development. For that, we'll have to make a trend that what meets the needs of present today, it should, without any compromise, it should meet the needs of future as well, so that the whole universe remains green, evergreen, what was it, and it will be in the future as well. Now, who will do it? As Einstein says, engineers create that which has never been, and others also said so. So it is our responsibility, the mechanical engineers, manufacturing engineers, to create things, innovate things, and make things much cheaper and easier, of course, higher and better quality. Now, nothing to worry, actually, the trend has already started, as you see, knowingly or unknowingly. Steve Jobs did it in 2007. I hope you can guess who did it. All these gadgets, television, camera, whatnot, all communication and all utility devices, which was weighing 1,400 kg in 1980, and just came to a smartphone, which is only 200 grams, done by Steve Jobs. So this is in his, he did it. And I'm happy to announce and show you that we also started the same trend, and we started in 1990s. We thought we'll make small products. We'll do micro machining to make micro products rather than using big machines. And we found that to make micro product, all these machines individually cannot do it. We'll have to have a machine which is much smaller and can do everything, which initially it was not accepted by people. And even the company where I was working, they said, no, ridiculous idea. That I left the company in Japan and joined in Singapore and US. And my first research proposal was to integrate all these machines into one machine for micro machining. And that time, roughly, all these machines were about 8 tons. Now we made a machine in 2003 and patented it, which weighs up 1 ton. So a good thing is that it started. And at the same time, if we look at for sustainability, what we need to do, we need to move from conventional economy to circular economy. That is the trend now. It started already. So what we do, we make a thing, we use it, dispose it, pollute, throw it and pollute it. But on the contrary, we will have to do something, make things, use them, reuse them, remake them and recycle them. But that, and then all this energy saving will be upward. I want to move left, minimize the use. So that's why we'll have to be not only circular, spiral economy moving upward. Okay, yeah, the basic, all of you know, I'm sure. Let me start with the concept of remanufacturing, taking it at the center, and we'll have to come with Industry 4.0. I'm not going to discuss all these things. We'll have to have a smart factory. We'll have to have smart life cycle data, and we'll have to have smart service. And around this periphery, there will be a lot of things, control system, non-destructive testing system, smart sensor, and all these things. The main player will be here, additive manufacturing. Whatever is spoiled, destroyed, or damaged, we'll have to do additive manufacturing to bring it to near net shape, and then we do different types of machining for different purposes. Okay. Now comes to, again, the starting point is additive manufacturing. Let me quickly go through the additive manufacturing, which you know already. Usually when turbine blades come, the wear takes place in the tip, usually in corner, and normal practice is to find the repair volume is extracted, and then filling is done, and then some machining is necessary. It is done. It's a common practice. So it has a lot of problems. It has boring defect, stair stepping defect, lack of fusion defects, porosity, and all these things. I'm not going to discuss because I'm sure it has been discussed by others. And for that, they need to improve the surface finish, basically either do grinding or polishing. So the grinding is a very conventional way, and later the polishing is done by laser, then abrasive flow finishing, chemical polishing, and all these things are going on. So these processes are there, or laser polishing, chemical polishing, abrasive flow machining, and all these, and machining polishing. I'm not going to go into those. It is there in the presentation. Now, what is the problem of this conventional machining things, conventional polishing things? Let me see, grinding and polishing to improve the surface finish. One slide I missed. Actually, usually after 3D printing, you get a surface finish of 3 to 10 micron, and by different processes, they can reach up to 1 micron. But surface finish is somehow acceptable. But main problem is when you do by grinding, there are cracks of different dimensions. And it could be macro crack, it could be nano crack, but there are cracks. As long as there is a crack in the surface is not perfect, that can be considered as a high precision, ultra precision part. So it cannot be used for high quality products, especially for optics. So then comes polishing. The main problem of polishing is a non-deterministic process. If the surface profile is not correct, then what we do, the reflectivity of the surface is not there. So for ultra precision parts and components, even polishing and grinding cannot be accepted. We will have to go for machining. So that there comes ultra precision machining. Now coming to advanced machining techniques in manufacturing, let me talk about 2 areas. One is micro machining, another is nano machining. Let me start with micro machining. Why is it so important? If we look at any fine components like watch parts, watch plate, bridges, and moving parts, all these parts are, as you see, very high quality, very fine, very small features are there. And a few more examples like gas and liquid thermometry, and all these things, if you see, very fine, all the features are fine, machining is fine, quality of surface is approaching nano. And these are another nano positioners, and these are all components of optic electric components. You see, so minor, but they must be very accurate. And we cannot allow them to just one component of the, as Professor Dixit was saying first day, is one component of the watch is damaged, we should not throw it, we should repair it, redo it, and remanufacture it. Okay. Now, talking about micro machining, how are you going to apply it in remanufacturing? Okay. Again, taking this picture, we'll have to do manufacture, which is basically composed of so many micro components or components with micro features. And additive manufacturing should be there, as I mentioned, but we developed, as I mentioned earlier, we developed a machine which is for especially only for micro machining. And one machine should be, our objective was one machine should do everything, conventional machining, non-conventional machining, all in micro level. But when we started, as you see, we have developed this machine, it does micro milling, is again micro EDM milling, reverse EDM, micro EDM, and on-machine measurement and micro turning, all these features, name it, it can do it. I'll elaborate further. So this machine, let me go to the problem of the machine. We thought of developing it. We thought we will do micro machining. Then, as I said, first of all, we need extremely high quality precision, motion accuracy, fine position control. These things were not there. Processes, I will explain it later. No successful micro machining can be done without hybrid machining. Really high quality products, you need hybrid machining process. And we need to develop these processes. These are not scaling down the conventional machining. Most importantly, the machine will have to have metrology on it. Otherwise, you cannot take out the part and measure it and bring it back. So all this, considering all these things, we had to develop a machine. Just to give a quick example how micro hybrid machining is necessary. If we try to make a hole which is only 50 micron, we machine an electrode of 50 micron, then we take it to another machine, to EDM machine to do it. EDM cannot be done. So we'll have to think of machining the electrode here and bringing the EDM tank below and then do it. Otherwise, buying an electrode from the market, clamping error will be there. So your target accuracy will not be there. Hole will be much more than 50 micron. So hybrid machining is necessary. All the details are later. So he developed a machine in 2003, which can do micro turning, micro milling, on machine measurement, micro wire DG, micro EDM, micro iridium, and with on-machine measurement, we have added laser as well. So the machine is ready now to do all sorts of machining in one setup. So that way, one big step has already been made. This is one of the features that after machining by turning, we do EDM, sacrificial EDM. We reduce the diameter and scan it at every stage. And finally, we machine the whole by EDM and the whole, which is about 6.5 micron. So, but just conventional machining without hybrid thinking, making a 6.5 micron hole is almost impossible. And it's still holding the record that this is the smallest hole with highest aspect ratio. While developing the machine, our objective was to do hybrid machining. We tried to hybridize many machines, even EDM and ECM was brought in together to do hybrid machining. And it's given talks in many places. I will not go into details of it. This is EDM surface. And after ECM, you get it. But you do it in two machines, then again, accuracy problem will be there. So we tried to do it in one machine. But question was how an EDM done in non-conductive media and ECM is done in conductive media. Again, I will skip those. We have done it using low resistivity deionized water, where dielectric strength is good enough to do sparkling and conductivity is good enough to do ECM. And finally, I show the surface. In normal EDM, bottom surface is rough, but we compound them together, hybridize, then you get surface finish. It's actually nano surface finish. As you see here, only EDM, then it is red line. When EDM, ECM together, you get this blue line. For red line, surface finish is 142 nano, and for blue line, it is only 22 nano. So this machine does a lot of things. And because of this machine, even we dared to do ductile mode machining of brittle material, which I will not go in details. We tried silicon, where nano indentation test proved that after depressing the indenter more than one micron, it cracks. So using that 1 micron as a critical chip thickness, we carried out up milling. And as chip thickness goes to 1 micron, it will crack. So we subdivided this 1 micron, less than 1 micron, into hundreds and thousands of divisions. Because the machine is absolutely accurate, we have been able to do ductile mode machining of brittle material. This is the brittle surface when feed rate is very large. Feed rate is 6 millimeter per minute. When feed rate is reduced to 4 millimeter per minute, you see the surface is partial ductile. When feed rate remains 4, but if we reduce the radial depth of cut, we can get perfect ductile mode machining. So playing with these cutting parameters, this machine can do ductile mode machining brittle material. Machine is absolutely accurate. Conventional EDM does this type of hole. For our machine, we get almost like a zinc boring hole. So this machine, to summarize, it comes with all conventional micro machining, micro turning, micro milling, micro drilling, and non-conventional like micro EDM, micro ECM, laser, etc. Everything. It has on-machine measuring device. It can do simultaneous EDM, ECM, and it can do laser. And the record holding hole is 6.5 micron with 10 times aspect ratio. So this machine is really very applicable for remanufacturing. Only thing, we'll have to add some more aspect, like we have laser, but we'll have to bring in additive manufacturing. Okay, now let me come to this hybrid and nano ultra precision machining, which we initially targeted only to generate high quality optics and ultra precision objects. But now I think we'll have to upgrade it to make it to do remanufacturing. Now, why advanced machining technique is necessary in remanufacturing? Look at this quad. Just one example you have seen. I'm sure all of you have seen this Hubble microscope took the picture of the universe in 2012. This is the quality of the picture of the universe. Now in Webb's telescope taken in 2022, you see the quality is much better, much deeper, because the optics quality is better. So we'll have to move on to make optics better and better quality. That way, even our all these inspections, measurements in even human body would be much better. I spoke to one cardiologist here. I said, how accurate are you in when you do the detection of, blocked arteries? They say most of us we go by assumption. So all assumption things have to be removed. The optics quality of all sensors, all optics components should be so good that everything can be seen accurately. And that is only possible if the machining quality is improved. And just in artificial machining, for instance, this is the object. This is a car light. If you look at the mold for it, the machining is so complicated, so delicate, so fine, so accurate. So this type of mold, if after using many times, hundreds or thousands times, then if it wears off, should we throw it and make it? No, it cannot do that. We'll have to remake it. So these molds are very expensive and complicated, high quality, high precision, require a long period of machining time. So we cannot afford to, because these are very expensive. We cannot throw them. So instead of refabricating the new one, we will have to remanufacturing, do the modification corrections wherever necessary by additive manufacturing, and then you do the remachining. Only a little bit of remachining can save the whole thing. And for that, our machine is ready because we have developed first of its kind optical vision system. This system can identify any defects, any damage anywhere, and can quantify the amount of repair necessary. So this machine is quite appropriate. With some more changes, some more improvement, some more additions, it will be absolutely useful for remanufacture of ultra-precision components. Now, how to do that? How to apply the advanced machining techniques for remanufacturing? Okay, let me share with you interestingly, when all this diamond turning for ultra-precision machining was done, even the theory was not properly developed, but we attempted to develop the theory and analyze the applications and so on. And after analyzing, we found that to make functional optical surfaces, most important, again, we need hybrid free form surface generation by machining. And through the integration of multiple free-form surfaces, as you see here, this is the picture. And that will improve the optical performance and provide new optical functions. That means it will no longer circular, it will move, it will be upward spiral moving technology. And challenges are there. We started solving them, and it is everywhere, used everywhere, as you see here, in digital camera, in cell phone, in automotive, in image devices, and LEDs, everywhere it is there. And in the electronics, if you see smartphone camera, motion sensors, and virtual reality headset for digital twin manufacturing, everywhere, and the lens for that. So everywhere it is coming, and it is coming in bigger and bigger scale. Just to give an example, the Hyundai has developed a lighting system for car, which can predict that, oh, there is no vehicle in front of the car, vehicle directly ahead, and whether several vehicles are ahead. So you see everywhere this optics, ultra-precision machining is coming in a bigger and bigger scale. And Hyundai has already started using this. And if you look, every driver is complaining, oh, blind spot, accident is because of blind spot. No, if you have a very high aspect ratio concentrator mirror, then you can avoid this blind spot, and it has already been developed, a side mirror without blind spot. So things are changing, and changing quite fast, and all are for the good use of human being. And to achieve all these things, you'll have to generate the free-form surfaces in optics, you'll have to do compound diamond turning. Compound means actually basically when you go for ultra-precision machining, on top of one-axis machining, you'll have to have first tool servo to generate on a plane surface features. And you'll have to couple it with a slow slide servo. This first tool servo and slow slide servo can make miracles. I'm not going to discuss the details. As you see the video here, when this first tool servo, the tool tip is moving against the C-axis at the very high frequency, ultrasonic frequency. And when this stroke length of the first twin servo get exhausted, then slow tool, that means the slide moves to machine deeper features. So this is the combination of these two. And by that, you can machine surfaces like this is a compound eye surface can be machined. And when it comes to remanufacturing, again, taking all these peripherals, we attempted all these necessities in mind. We tried to develop a machine which is really state-of-the-art, first of its kind diamond turning machine. This ultra-precision CNC diamond turning lathe, which produces optical mirrors, lenses, multi-lenses, mold inserts, free-form surfaces. Okay. Now, again, another reason for doing that, if you look at this Taniguchi prediction, Taniguchi, famous Japanese scientist who predicted how this accuracy level or surface finish level will move forward. In 2020, he predicted 1 nano surface finish should be there. Unfortunately, we are yet to reach 1 nano, though we have crossed 2020. So I think we are not really, our technology is not up to the expectation. So we attempted to develop a machine which can at least machine 1 nano surface finish. And we hope the machine we have developed can achieve less than 1 nano surface finish. Let me explain quickly. What is the how? First of all, we had to develop the theory. Usually, people are doing diamond turning without knowing the theory of why and how it happens. We tried to attempt 2010. We did one project, and people think the tool edge is infinitely sharp, which is not. We found there is a roundness, and we thought that roundness is causing the problem. So there is roundness, edge roundness of the tool is R, and taking the chip thickness A. Again, I will cut short the discussion. This A by R, chip thickness with edge radius, A by R causes this problem. And after analyzing, we found that when A by R is greater than 0.25, then extrusion shearing takes place. Everybody, all of us, we know shearing and plowing. And in between what is happening, we try to investigate that. And we found that when A by R is less than 0.25, that reverse flow of the material takes place, which resembles to extrusion. Thereby, we developed this theory of extrusion-like mechanism, where the reverse flow of the material takes place. And this is concentrated shearing, which A by R is large, and here A by R is very small, below 0.25. So first breakthrough came, and it was done in 2010. Now at A by R 0.25, we get absolutely very clean surface. Beyond that, surface becomes rough. Below that, surface becomes rough. These are all details. But again, we continued. What happens? Can we go beyond that? This also, I'll make it very short, quick. And we found in another study that when A by R is 0.05, we get even much better surface. So all these theoretical analyses substantiated by experiment gives us some confidence that definitely the time has come. We should get ready with a machine to achieve surface finish less than 1 nano. So the machine comes with special features like 8 picometer linear optical encoder with 0 to a glass scale. And I am happy to say this is the first scale in the world with such a high resolution of 8 pico. And our in-house cam, we don't buy cam system, we develop our own cam system with the graphic user interface, very user-friendly. It can do aspheric, multi-lens arrays, Fresnel lenses, free-form surfaces using fast and slow tool servo. So it is absolutely. Most importantly, it is the first of its kind optical vision, which can take all measurements, tool length, tool height, and tool nose, edge radius, workpiece diameter, everything below 1 micron. And again, as I mentioned, that whole complete software is supported by our own user graphic interface. And this is a system, vision system. This can, from the top, it can measure the tool edge. And then when you bring it to the side, it can measure cutting edge from another direction. So it's a 2-directional measurement. That way we can measure the workpiece dimensions as well. And as I mentioned, so this machine again comes with slow slide servo, first tool servo. Most importantly, is another device we have incorporated here is ultrasonic elliptical vibration device. So that's very wonderful. Others are yet to add it. And slow tool, first tool, I will skip quickly, and I'll go to elliptical vibration device, which is, please listen to me carefully. Because of these devices, you see, this is the device in operation. And you see the work is here and field is cutting. So very difficult how it is moving the elliptical path. I quickly take it to the next journey. This is the tool usually in ultrasonic cutting. Tool is in touch with the workpiece and it is vibrating continuously with the small amplitude, first tool servo, and cuts. But here, that way, the tool life is short, and then once tool is damaged, then surface becomes damaged. Here, elliptical vibration tool moves in elliptical path, though it looks circular, its axis A and B can be changed. It has a mechanism, then you can change the shape of the ellipse. And this is the thing, more details. Conventional cutting, only one directional vibration, and elliptical cutting, the tool is rotating in this path. As you see here, more elaborate, as the tool comes in, cuts and moves away, that way it moves in elliptical path, changing the A axis and B axis, depending on the material, which axis will be longer, which will be shorter, you can decide and determine. That way, your cutting force is minimized, surface finish better, tool life is much better. And as I mentioned earlier, using upmilling, you can really generate ductile mode surface. You can do ductile mode machining, the upmilling, and in this elliptical vibration device, exactly same thing is used. Upmilling principle comes in, and I'm sure it is very clear now how this elliptical vibration device can cut brittle material. So using this elliptical vibration device, you can cut any material you want, whether ductile or brittle, ceramic or silicon, steel or aluminum. Yeah. So this is the principle again. In conventional cutting, the cutter moves in one direction. In elliptical vibration cutting, it cuts in elliptical path, in two-dimensional cutting. So this is the device. And if you look at this, the video, as you see, the chips are flowing as if powder is flying away from the machine. Chips are so fine. And then if you skip, then this is another example of machining being done. Okay. And we have machined tungsten. And as you see, we have machined tungsten. Others are saying that no, tungsten is difficult to machine. We have very easily we have machined using then PCD, polycrystalline diamond, and single crystal diamond. If you use polycrystalline diamond, surface finish is about 7.6. If you use single crystal diamond, you can get a surface finish of 4.5, though it is brittle material. But slowly we hope to improve the surface. Again, for even brittle material, we are targeting 1 nano. And these are some more examples. And you see the machining reflection is so clear, surface, you can see fine lines. This is machining of tungsten. Yeah. Now coming to what are the cases it can do. We even got surface finish of 2 nano. These are all nickel plated die. It's 4 nano. And you can see the reflection quality. And using slow tool servo, we can generate these features like this, and sinusoidal surfaces. And using first tool servo, you can generate surfaces. As you see here, hundreds of pyramids are machined on the surface. And again, combining slow tool servo and first tool servo, you can do all sorts of hexagonal lenses, multiple compound eyes, and so on. So I would like to finish here. Thank you so much for listening.
Thank you, sir. Thank you, sir, for your enlightening presentation. So now it's time for a question answer session. The house is open for question answer. If anyone has any question, participants, you can ask post in question answer session this section. or you can raise your hand. You can raise your hand.
Chat box, just have a look at chat box.
Yeah. You can put in chat box.
Sir, I have a point.
Yes, please.
Actually, many things are advancing very fast at different corner of the globe. Often we procure some equipments, but very often we find that there is trouble with maintenance, there is trouble with operation. Sir, can a micro tool organize some training program for our young faculty? Maybe with proper fees and remuneration, because you know that in India, every faculty are now having CPDA. So to go to Singapore and to have a training is not much difficult for them financially. As ARTC, I came to know they are conducting a program for 24 hours for in the remanufacturing area. So, sir, I just it is just my appeal for your thought. If you find it is relevant, I believe, sir, it will be a favor for the young faculty members to move to the advanced frontier of remanufacturing or micro manufacturing.
If I have understood clearly, I have two answers for the question in two statements. You see, maybe oversaid, exaggerated, but it's not exaggerated. Rolls-Royce doesn't listen to happen that their car failed somewhere. And one Maharaja of India bought a Rolls-Royce which had breakdown in Himalaya. So before it was published in the newspaper, Rolls-Royce company sent a maintenance engineer to repair it and said that no, there was no trouble at all. So having said that, we microtools, we guarantee that we have so many machines in India. None of the users have any complaint that we have problem in repair maintenance.
I'm not talking about problems, sir. I'm talking about application of this machine.
I'm coming to that. And so assure you that we take care. And our first machine is in India now. And the micro machine, there are many. But the diamond turning machine, one in India. And that place, we are going to have a 1 week training program for anybody who wants to come.
Great,
We'll
great.
run a course on that, saying that this is the way it should be used. And we'll invite users to give their points, what else they want us to incorporate. And that will be our permanent training center, service center, maintenance center. We have already appointed one guy and we will appoint one more guy.
Great, sir.
Yeah.
That will be a
And
great
if
favor.
anybody wants to come to Singapore to see, again, they can see, but that short courses are, I don't know how useful they are. But any sort of collaboration, cooperation, anything you want, just let us know.
Right. Thank you.
Thank you. Thank you, sir. Yeah. So there is one question, sir. So I
Yeah.
think, but this is not. It is
Okay,
about
very
Indian. You can read that question, sir.
Yeah, I can see. MSME
Any-
equipped with such high precision equipment. A role vital. Yes. I give you answer in talking. As I told, there is one machine in India and 3 more machines are on the way. So we hope to make a big impact in India. There will be a lot more machines and this machine is offered the highest quality and very competitive price. Much cheaper with a guarantee to service.
Thank you, sir.
Thank you.
So thank you, sir. Thank you. Well, like I would like to take the opportunity to present the vote of thanks to you on behalf of NIMT and FMFI. And it's all like I would like to express our gratitude to you, sir, because you spare your precious time and given this enlightening presentation on micro machining, and you have covered like so many aspects of micro machining and ultra precision machining, which can be of useful for remanufacturing. So once again, thank you, sir. Now it's
Thank
time for, yeah. So
thank
I
you so
think, sir,
much for attending.
yes, sir. Thank you, sir. Now it's time for us to move to the second session of today. So second lecture is from Professor Uday Shankar Dixit, sir. So sir has already joined. So sir has joined. So other panelists also joined. Good morning, sir. Good morning, Shri
Yeah.
Satyamita Patnaik, sir, also. Both of you. Yeah, welcome, sir. So now, sir, before starting, I would like to give a brief introduction of Professor Dikshit, sir. So, sir, I'm Himanshu Khandelwal from faculty here from Foundry Technology Department, and I would like to take this opportunity, sir, to welcome you on behalf of FMFI, but you are the chairman of FMFI, and this this NIMT. So, sir, Professor Dikshit has received a BE degree in mechanical engineering from University of Roorkee, which is now Indian Institute of Technology, Roorkee, in 1987. Sir is done his MTech in mechanical engineering from IIT Kanpur in 1993, and PhD in and his PhD is from IIT Kanpur in 1998. So, yeah. So he was also he is also officiating the director of Central Institute of Technology, Kokrajhar, from 2014 to 2015. Professor Dikshit is actively engaged in research in various areas of design and manufacturing since last about 30 years. So most of his research work is focused on modeling of manufacturing processes and involved finite element analysis of elastoplastic problem. He has co-authored more than 120 journal papers, 111 conference paper, 31 book chapters, 7 books in mechanical engineering, and many more. He has also co-edited 7 books which is related to manufacturing. He has guest edited 11 special issues of the journal. He is an associate editor of Journal of Institute of Engineering, Series C, and regional editor Asia of International Journal of Mechatronics and Manufacturing System. He has guided 12 doctoral and 44 masters. I think this is again old 1 year before studies. I don't know, sir, the correct. So Dr. Dikshit has investigated a number of sponsored projects and developed several courses, including NPTEL course on engineering mechanism. So Professor Dikshit also act as the chairman for this futuristic and advanced manufacturing forum of India. So apart from being the speaker of this guest, Professor Dixit is also he also act as a mentor for our institute, and he is helping us in from NIFT to the transition between NIFT to NIAMT. So with this remarks, sir, I would like to welcome you. So yeah, Sai, over to you, sir.
Yeah. Thank you for introducing me. Although I came in inauguration program also, and naturally I am very much associated with Humphrey. So that way, and let me share my slides, and then we can discuss something. So yeah, just 1 minute. Okay. Yeah. Acha, is my slide visible now?
Yes, sir, it's visible.
Yeah, okay. So mostly I'll be concentrating on the design aspects in remanufacturing, that how you should design the product. That is one issue, and maybe some more points, because there are lots of participants, and many of these participants may not be very much familiar with remanufacturing. Although remanufacturing is not a very new technique, people have been doing it in some way, but as a mass movement, in fact, it is somewhat a new technique only, because you know that how it will be done as a mass movement, how it will be identified as an industrial activity actually. we have been doing such type of things. Suppose there is one machine and we renovated it, we put something, but that is only on at the level of one or two machines. But now we have to discuss that how it can be taken as a mass movement so that it can help our economy and it can be useful. So what capability we have already got, all these type of things we will discuss in that about half an hour. So what is remanufacturing? It is the process of returning a used product to like new condition. There are many definitions of remanufacturing, but one is that it is the process of returning a used product to like new condition. And it results in cost saving in the range of 20 to 80%. And quality can be made as good as a new product. In fact, the warranty is also given like a new product. So this is this one, but there are some more people have also defined that one definition is the process of bringing an already used product to a new condition through replacing and rebuilding component parts. Usable parts are cleaned, refurbished, and put it into inventory. Then the new product is reassembled from both old and new wherever necessary. So this definition tells the process also that you have to get the old component, you have to see the component, you have to inspect that thing. Now here there is a lot of scope for non-destructive testing and even the analysis to predict the usable life of the items and all those type of things. Now, next one definition is that an industrial process that transforms end-of-life product into a product with as good as new condition. It comprises product disassembly. First, you have to take the product, you have to disassemble that, cleaning, and then identification of the parts recovery, and product reassembly. Material recycling occurs when parts and components cannot be reworked. So there is a difference between remanufacturing and recycling. In recycling, actually, you take the component and you recycle it again. Say, suppose I have got a component made of steel and then I send back to foundry. Again, it will be made steel. That type of thing also can be done. And so when the parts cannot be used as it is, then they are even they cannot be reworked. Then they are sent to recycling process. But recycling generally will take a lot of energy. So as far as possible, parts should be used in their full form, and with minor modifications, they can be fitted again. So remanufacturing is a process where the broken down or used products are restored to useful life. A product is reprocessed or upgraded in an industrial process. The used products, parts, components used for remanufacturing are referred to as cores. We call that, in technical terms, we call cores. So we have to get a lot of cores also. So there are a lot of issues connected with remanufacturing, that if you take up it as an industrial activity, then we also have to worry about supply chain, and we also have to worry that suppose product components should be reusable also. So that means at design stage also some thought has to be given that this particular machine will be remanufactured. So in what way it can be remanufactured? So before that, discussing that, let us discuss some of the advantages of remanufacturing. One is the sustainability, that it costs less to make and buy remanufactured product than equivalent manufactured product, and it implies skilled workforce. So two advantages you are getting. That means one goal is in fact economic one and environmental, because cost will be less, so you will be saving the money. And the environment benefit will also be there because it will be taking less energy. So less energy consumption will be there. And social side, there is a benefit because sustainability means economic, environmental, and social aspects. So social side, that it implies a large amount of skilled workforce. So workforce will be there, and you will be utilizing that thing. That is this one. So it saves energy needed to manufacture new product, consumes natural resources, and reduces landfill disposal to manufacturing new product. Many times what happens, like some in tire industries, sometimes the huge tires are cut into pieces, they are shredded, and they are used as a landfill. They are used in road construction also. But such type of activities in long run may pose a lot of danger to environment. So it is better that they should be reused. Upgraded products work more efficiently than previous new product, because you will employ some latest technology, so they may work more efficiently, and it promotes circular economy. Naturally, that here nothing is wasted, so it promotes circular economy, and remanufacturing requires skilled workforce. That is also good point, because you can train number of people to come in the job of remanufacturing. Then performance, remanufactured product works as well or better than the previous product. So this should be remembered, that product should be working much better than the previous product. And responsibility, companies are increasingly being held accountable by stakeholders for environmental impacts from their supply chains and products during their life cycle. So this aspect is also very important, that now who should take remanufacturing, whether it will be original equipment manufacturer or other industries. Now it is better that original equipment manufacturer comes in the business of remanufacturing, then the quality can also be ascertained, and maybe that company can also develop other ancillary units which can help in the task. So this aspect. Now, what are the steps in remanufacturing? So these are the steps that, first we have got the component, and then we have to do that sorting, inspection, then disassembly of the components, then after that cleaning and reprocessing, and then after that reassembly. So this type of process is followed, but maybe after disassembly also you will get component, again there will be some inspection, but more or less these are the this one. Remanufacturing includes the replacement and repair of some parts. Some parts may have to be replaced and some may be repaired. Now, because remanufacturing you may not do in the large quantity, it is natural that suppose a original equipment manufacturer is making some product, let us say automobile. So if there is a production of say 10,000 cars, new cars, maybe the remanufactured car will be less in number. They may be about maybe 1,000, maybe 10%, 20%, or maybe 30%. So what happens that there is a problem that you do not have maybe mass production in all the cases. And that's why 3D printing becomes very important, because suddenly if some component is not there and you have difficulty, it may not be in your inventory stock, then it can be remanufactured by 3D printing. So the role of 3D printing will be very vital. And of course, the repair of the parts, for repairing work also 3D printing is best suited, because you can particular portion can be easily 3D printed. Otherwise, repairing is very difficult. So additive manufacturing is very good. This one is actually a metallic 3D printer, which we recently procured at IIT Guwahati. So such type of metallic 3D printers can be used for remanufacturing task. Now, remanufacturing is naturally the part of the sustainability goal. Sustainability means it has to be environmental sustainability, economic sustainability, and social sustainability. Now, in the present era of sustainability, you know that remanufacturing has a lot of significance. One is that economic side, it lowers cost and it increases the profit. And environmental side, it does resource conservation, less energy and less pollution, then better health for people and planet. And on social side, that it has a lot of scope to provide employment to people and particularly create skills for the job. So this is, and another one is in sustainability, cultural pillar is also there. So even on cultural side also, the remanufacturing may help, because that old things that can be preserved. You see, the way we are also fascinated to preserve the old. No? We have vintage cars and all those type of things. We want to preserve our heritage, so that heritage can be actually preserved. Many types, some good product is there which is coming from the grandfather's time. You don't want to throw it. Suppose there is a chair in your house, even that particular chair, if it can be remanufactured, it will be always better. So that means remanufacturing can be, in fact, in each area. And today we are discussing, in fact, in the context of the industrial products, particularly the mechanical one, but remanufacturing is equally applicable even for buildings, etc. Nowadays, many buildings are also being made. They can be also remanufactured, provided we design in such a way. Say, for example, houses can be made by 3D printing also. So that means we are making the houses by 3D printing, and those houses after some time, naturally they can be remanufactured. So recently IIT Madras also made some rooms in using 3D printing. Germany also had made some houses. So the present days, many things will be made by 3D printing, and naturally there will be scope of remanufacturing. So remanufacturing is not limited only for the mechanical thing, but it is at many places. Even temples can be constructed again. So that means our culture can be preserved, and temple can be, in fact, the same type of architecture can retain for years. So it has this one. So remanufacturing is usually carried out by original equipment manufacturer, but OEM can outsource it. So this way, many industries can be created, and naturally it has got huge scope for employment generation. Now, role of reverse supply chain manufacturing, that means how it will be achieved, that is very important. That means company can give buyback offer, like old PCs, they can be purchased back. Even old cars can be taken by those companies. This type of thing, naturally, governments also have to enforce. So remanufacturing can be fully successful only if the government also takes complete interest in it, because many times you have to tell the manufacturer that they should think about something, life cycle of the product and how it will be remanufactured. Otherwise, many times this one, like we used to have this system. Coca-Cola company was there, so we used to, it was compulsory for us to return the bottles. Actually, if we purchase that, they will give a crate, and after we consume it, the bottles will be taken back and they will be refilled. That type of system was long back, even starting from 80s and in Coca-Cola. In fact, once I procured a lot of bottles for a family function and some bottles were missing, then they took money for that, because they need that complete bottle. So this type of thing, in fact, can be done. Many people don't know that there is a system to return back the used cartridges also, and in that the ink can be filled. But I have seen at many places, people just throw them out and they don't get it filled, and it generates a lot of e-waste. So there has to be such type of things have to be enforced by the government in a very strong way, and even social awareness should also be there. Then it can be successful. Now, after the used thing can be recovered in various ways, alongside with the remanufacturing, in fact, other things also should be paid attention. It's not, remanufacturing has got many sisters also. So we have to take care about those sisters also. That means equal attention should be given to recycling, because sometimes, some components may not be used in remanufacturing. They have to be recycled. Okay, so this is one thing. Then third thing is reuse. Like we used, we recently, my students worked on that thing, that suppose chips are produced in metal cutting. So those chips were used for making the bamboo composite. 2 strips of the bamboo, in between some epoxy, and then the chips were filled. So they were used to make some pavements, etc. This type of work was also done. So this is also, and then cannibalization. There is another that process of recovery that where you know that the products are basically used and basically they get consumed. Okay. Then waste disposal, that is forward. So waste disposal is another thing, that recovery, another is waste disposal. So our attempt should be to reduce the percentage of waste disposal and enhance the recovery. And so this is the example of that. This is forward supply chain, that where the product just goes and we just it is thrown, and in the reverse supply chain, that how the product will be taken back, how it will be stored in the warehouse, and how will be this thing. So because there are some issues, because on one side we say inventory should be minimized, on the other side there should be some way out, so that when we are remanufacturing, then we can get this one. So that also has to be dynamic chain. Anyway, other people will speak on supply chain side, but I am just indicating it here. So features of remanufactured product is like this. Remanufactured product basically looks like a new product, lower in price and good performance, good warranty period, and it has got good lifespan. And now if we compare remanufacturing, repair and reconditioning, there is a difference between repair. Everyone knows repair means if some defect is there, you just get it repaired, and reconditioning means that you know something, renovating it means putting something. Suppose there are many parts damaged, you recondition it so that it becomes more strong. That is this one, but it is not remanufacturing, because remanufacturing of course make it totally new. So repair, remanufacturing and reconditioning, work requirement, repair is low, reconditioning average, but remanufacturing high. So that means employment generation point of view, remanufacturing is a very good option. Then performance wise, repair, it is low performance, because you repaired it, but after some time again it will go. Reconditioning is average, but remanufacturing is a very high performance, because it is a product is made like a new product, and even testing standards will be same. Quality assurance will also be there, and this is how it goes. Now cost incurred. So cost in repair, it is of course low, reconditioning average, but remanufacturing will be high in comparison to repair. But this high cost is worth it, because it is, you are basically purchasing a new product. Warranty of the product in repair, it is low, reconditioning it is average, but in remanufacturing it will be very high. So remanufacturing saves energy as well as money. And some examples already that some remanufacturing activities have taken place, and these are like remanufacturing of photocopiers, the Xerox machines, then cellular telephones and single-use cameras. They are being this one. So cost component actually is material cost, labor cost, and overhead. Now, if we compare that manufacturing and remanufacturing, then cost component is like this. Material cost in manufacturing, it is very high, but in remanufacturing, this is low. So remanufacturing shows a lot of material cost. Labor cost in manufacturing is low, but labor cost in remanufacturing may be high compared to this one, because in manufacturing you have got a product line, suppose automobile, so everything is going on, and you have brand new products, and they are just getting assembled in an automatic way. But in remanufacturing, you have to see carefully that which point parts can be used, which cannot be used, and what is this thing. So maybe as of today also, it may not be possible, just because with the help of robots. Actually, human intervention is needed to take decision that which part to throw and recycle, and which part can be used again. So in a way that here the labor involvement is more in remanufacturing, but cost of the material cost is actually low, and in fact overhead cost is also low, but in the manufacturing the overhead cost is high. So that means this is a very labor oriented work of remanufacturing. Labor also is of skilled kind. Lot of engineers will get employed and they will see that there will be various tasks from the design point of view and from even material testing point of view, because non-destructive testing will be there. Then there will be some analysis by which they can estimate that remaining life of the product, and so many things of that type of. Now with remanufacturing, recycling is unavoidable. As I already said, that you can do remanufacturing, but you have to do some components have to be recycled, they have to be used again. So recycling is the process of converting waste material into new materials and object. So you may have like in machine tool industry, you get chips, and then those chips can be again put into the furnace and we can make a new product. That is one recycling. When the parts are too damaged to undergo remanufacturing process, they are fed into a recycling process. So side by side, recycling industry should also be there. There should be provision of that. Now, what are the basic problems in remanufacturing? What challenges we have to face? So one is the material flow. We should get sufficient parts, because these issues become very important. Recently, I organized one industry academia interaction at IIT Guwahati. Then some people from industry, they were discussing that in cement manufacturing, for example, there is a regulation that some amount of fly ash should be also added in the cement, fly ash which comes from power plants, etc. But in Assam, they are getting problem in getting sufficient amount of fly ash. So although it is just waste, but they are not getting. So similarly, if suppose I set up one industry based on remanufacturing, that means it will use old car components. But if those components are not available to me, then there will be some difficulty. And you cannot artificially create those components. They have to be this one. So many people think that with remanufacturing, the fate of manufacturing will go down and new things will not be manufactured. No, new things have to be manufactured, because unless new is there, then how you can get remanufactured? And this question also comes, that how many cycles of the remanufacturing can be done. Suppose I make one automobile and then it is remanufactured, then it also finishes life, then again can it be remanufactured, like okay, then the third time, fourth time, like that. But naturally there has to be production, new components have to be made. So then only you can get the material. Then requirement of space, you require a lot of space for storing this one. Suppose used cars are there, they have to be kept somewhere. And it has one problem is that how to cope up with the high inventory level, because you have to collect from this one. Till in manufacturing, most of the things are taken from suppliers and vendors, etc. But here your vendors are distributed. They are thousands of people who are owning the car. From there you have to get the component. So this inventory, how it will be managed, that is also issue. Then uncertainty in the quality and number of used products, because naturally when a vendor supplies you some product, then each part is of same quality, but here that you are taking from different sources. So that means there will be lot of scope for material scientists and those people who do stress analysis, design, because to assess the quality of the products and accordingly take corrective action. So that is also an issue. So these are basically 4 huge problems that we have to take. But what are the incentives of remanufacturing? What are the driving forces? That is, one is the market demand should be there. So market demand has to be created. So public awareness, this type of seminars, in fact, will create awareness. At least that one objective is that people aware that yes, remanufacturing has a future. And another, registration, that means government can do that if they give some incentive on purchasing this one, like in Singapore, etc. There is if you purchase that new car, you have to pay lot of amount in the form of tax, etc., environmental tax. But here in remanufacturing, you can see lot of benefits to even to purchaser also and to manufacturer also, because the government knows that if the product is getting remanufactured, then it is consuming less amount of energy. So maybe can we make some policy in automobile sector that if the car is remanufactured, then road tax will be less than in the brand new car. If we can do this type of thing, then it will encourage many people to purchase the remanufactured product and this one. So even insurance amount, etc., can be reduced in the remanufacturing cases. Then environmental issues, naturally it is benefiting our environment, so remanufacturing should be encouraged. And requirement of remanufacturing is that components should have significant residual value at the end of life. This will be always there. Suppose we make a machine, let us say a simple example, if there are 10 components and then all 10 may not have the same life, but we know that like in a chain, the life of a chain is determined by the weakest link. So one link has broken, then the part has actually failed and its life has gone. But other parts are good, like in the chain example, that if it is true that life of a chain is determined by the weakest link, but if the weakest link has failed, then the remaining links can still be used. That should be our slogan. That means remanufacturing means making use of the other links which were not the weaker and bringing them back into the new form. And remanufacturing firm should be able to capture the retired product. That is very important. So that means when they sell the car, any product, say machine or car or anything, there should be agreement that they should take back the product after some time. Product should be restored to like new condition with only modest investment. It should not require huge investment. So that means here design should also be done in such a way that with modest investment it can be done. And these type of things can be thought, like many times instead of welding, if we can go for riveting type of thing, or maybe by fastening type of thing, so that the parts become easily reusable. Reconditioning versus remanufacturing. Reconditioning is the process of returning a used product to a satisfactory working condition that may be inferior to the original specification and warranty is less than the newly manufactured part. But remanufacturing is the process of returning a used product to at least OEM original performance specification. From the customer's perspective, warranty is at least equal to the new product. So what are the barriers to remanufacturing? That means technology advancement, components become obsolete. That is one thing, that technology will keep advancing. Then how you will do this one? Like example is that in CD drivers, etc. Earlier we used to have floppy disk. All these things have gone. So naturally they cannot be remanufactured. So that is one thing. Then lack of effective remanufacturing tools. This problem has to be overcome. Then poor customer perception. So this is now we are making awareness, because by organizing such type of workshops and maybe in future many conferences of such type, we will create good perception among the customers' mind, and industry also will create good customer perception by advertising. Then low demand, high selling price, high lead time, and then banned product. Some products are banned, they cannot be remanufactured. Like example is the refrigerators. Because of the refrigerants, now the technology has to be changed. So this is, and the other thing is of course the IPR issues, that although a lot of MSMEs, etc. can come into the business, but sometimes there can be patent issues. You cannot just take decide to make remanufacturing of a car or something. So there are then design issues are of course there. Parts get damaged during removal and cleaning process. If designer has not made in such a way that the parts can be easily disassembled, then it will be very difficult. Many times designers use a lot of plastic items, and they are totally sealed. If you take it out, it gets totally damaged. Use of rubbers and plastics in design may affect this one. So they have short life. And in fact, rubber and plastics create environment. This one, so once upon a time, we switched over to rubber and plastics. But maybe from remanufacturing point of view, we may think that maybe using the metal may be more economical. And then screws, rivets, welding, strong adhesives. So we have to decide screws, etc. Very easy to disassemble. Riveting also can be done in some way, but sometimes welding makes it permanent joint. So we have to think about that. So what is the present status of the remanufacturing? Majority of products that are currently remanufactured have not been designed for remanufacturing and business. So that is this one. That means as of now, they have not given much thought, but there is growing interest in product recovery, recycling, remanufacturing, reuse, repair, and refurbishment. All these are this one. Refurbishment is the act or process of cleaning, decorating, and providing it with new equipment or facilities. So these are the steps involved in remanufacturing. That core acquisition, core components are required and sent to necessary facilities for processing. That is called core acquisition. Then disassembly. At the remanufacturing facility, the failed components are completely dismantled. Condition assessment, every dismantled part is inspected. All parts are sorted according to whether those parts are usable, unusable, or need repairing. Then cleaning, usable and repairable parts then undergo cleaning process, and unusable parts, they are sent into recycling or waste disposal. Repairs and necessary improvement to the parts are made using advanced manufacturing processes, and they rely on the expertise of the staff. So about repair, Professor Rahman was just now telling about that. Repair can be done using advanced manufacturing process like machining, etc. And then assembly, then again all the parts are reassembled and a new product is built. Any required new parts are also incorporated. Then testing, the performance of the remanufactured product is tested and evaluated against the specifications. Then service life, the final remanufactured product is commercialized and begins its new service life. Then core return, after reaching the end of its useful life, the product is sent back into the remanufacturing process to evaluate if it can be remanufactured again. So like that, this process continues and this becomes completely circular economy. Now, what is the role of 3D printing in remanufacturing? This from a latest paper, I took this data that 3D printing technology has been used in different industries. In marine and offshore, it is 22%, power plant 22%, railways 11%, aircraft it is 28%, and manufacturing it is 17%. So in manufacturing, there is a lot of scope for 3D printing. And 3D printing technologies for repair and restoration, that powder bed fusion 7%, fuse deposition modeling process 17%, but direct energy deposition has big role, that is 86%. That is basically metallic 3D printing, etc. So it has got a big role in that. And then different components repaired and restored by 3D printing, that basically die 11%, turbine 39%. In fact, Professor Rahman rightly gave the example of turbine, that how turbine can be, because that tip gets damaged and then it is 3D printing material is deposited and then it is finished. So turbine, engine 17%, rail 11%, and other 22%. And so this is the damaged tip, and this one I think similar type of item was shown by Professor Rahman also, and then it is after that laser cladding was done. So it became that with the help of laser cladding or 3D printing, you can actually make a new type of tip. Okay. So challenges and barriers. So only 9% of the 92.8 billion tons of minerals, fossil fuels, metals, and biomass that enter the economy are used annually. This is a circularity gap report of 2019. So, and there are not enough remanufacturing awareness programs at academic level, because remanufacturing as a subject is also not there. In fact, we can slowly add remanufacturing, if not as a subject, but at least as a chapter. Maybe in 2-3 lectures, we can cover remanufacturing also in manufacturing courses. Remanufacturing equipment is not readily available. That is also one thing. There are not enough regional innovation research and development projects. Okay, so we have to get now DST, etc. should also give some funding in this line so that projects of remanufacturing can be taken up by researchers. A scarcity of human capital with sufficient technical knowledge. Okay, that is one thing. But although we have this one, we have expertise, same type of things will be used, non-destructive testing, and even the process of making skill of repair, all will be used. But right now there are some problems. At policy level also, that means if there are some policy makers in this sitting, or this information can go to government, that there is a lack of environmental laws and regulations, policy makers lack of support, a lack of financial incentive is there. They have to reduce. Then incentives for growth of new industries are lacking right now. Tax burdens are excessive. There is a lack of coordination among government agencies that provide services to the industrial sector, and lacks of marketing strategies. These are the problems of not only our country. I am talking basically in general, because I have seen many sources while preparing this lecture. So in other countries also, these are the same problem, that taxes should be reduced. That is the demand of the manufacturers of all countries, not only our country. So our country also should do this type of thing. Industry level, what are the problems? Remanufactured goods have a low demand, a lack of desire to return used goods. It is difficult to set up a system for returning used goods. That is one thing. Then balancing supply and demand is a difficult task. Struggling to stay competitive with a brand new product. Then long-term investment is needed to start a remanufacturing company. Investment in the remanufacturing industry is not financially viable. Manufacturing industry is suffering from lack of investment, uncertainty of quality of returned used items, and complicated due to a large number of product models and variations. So there are a lot of challenges. That means industry needs a lot of support from policy makers and academicians. So this is the mostly I just give some overview or some thoughts that how we academicians have to think about this remanufacturing and how we can how to help in this one. These are the some references from which related to remanufacturing particularly we could get, and this is all. So okay, so now if there are any questions we can discuss.
Thank you, sir. Thank you for your lecture. So sir, there are questions in the question answer section.
Yeah.
Shall I read out or
Yes. Fine.
Yeah. So there is one question here. This ND from some anonymous attendees.
Okay.
ND plays important role in remanufacturing, keeping
Yes.
in the view micro machining, micro manufacturing, additive manufacturing. Is ND at par to contribute? And what expectations remanufacturers have from ND experts?
Right. So in fact, remanufacturing needs lot of ND experts. ND will have a much bigger role, because to assess the quality of the product after its service life is over, then the product has been taken back, then the components have been sorted out, and then cleaning has been done. Then you have to assess that what is the life, is there any flaw, is there any crack, and along with the ND, we need to side by side, we need the people who can do that basically life prediction analysis or reliability analysis. Okay, what is the reliability that this one? So NDE will find out basically if there is a very small amount of crack, but how much time it will take to grow this one. So what will be its life? And even in the new one, suppose then I did some additive manufacturing, I deposited the material, but the material should also not have any flaw in between. Okay, so therefore NDE is needed there also. So in fact, NDE will have much bigger role now in remanufacturing process, and therefore there is a huge scope. So therefore, those people who are working in the design field, they have to come up with the this one, because life prediction models also have to be used very efficiently. There are already some models, but they have to ready to use them properly and to develop their own models also. In fact, machine learning will also have big scope there, because based on the information, all the data should be stored, that this will be taking this much time, because what is their experience, what is the life of a typical component. So this type of thing is this one. So this will be having big role. Yeah. So yeah. Now yeah. So how efficiently you find NDE in present day scenario for helping in supporting micro machining? I think Professor Rahman wants to answer this question actually, because it is written, is it not? Yeah. So Professor Rahman can answer this one. Yeah. If Professor Rahman is there? Yeah. If it is not, no, not there. Okay, anyway. So I have answered this question. So it's okay. I think that NDE will have big role. Non-destructive testing is very important. Any other question? Next. Sir, could you please suggest and discuss some most competitive technologies industry available for health checkups of assembly, disassembly parts, particularly for machinery manufacturing, especially for mining, steel, nuclear, defense and space research sector? Okay, it is also related to that one. So this is there are some techniques like techniques based on the ultrasonic that they have been used since long. Okay, and they will be, then there are some radiography techniques, and there are now with 3D printing. See, residual stress becomes very important, that how much residual stress is there. So for that, the best technique is now like this one, neutron deflection, etc. So in fact, I recently heard a news that, you know, that they are making some turbines using 3D printing, and they are using neutron deflection technology to find out whether there are any residual stresses or not. Because the 3D printing introduces a lot of residual stresses, etc., because of the nature of the process, and it introduces a lot of thermal stresses. So these are the main items that which will be used, and there are some other techniques also getting developed in this one. Okay, I think Professor Rahman is there here. I think
I'm here,
Professor Rahman, yeah, you want to answer something about that non-destructive testing thing?
yeah.
Yeah.
Definitely, it will have to be only non-destructive testing, because we cannot damage the part further. There are non-destructive testing methods available. Commercially available systems are there. So, and that should be for remanufacturing. It should be non-destructive testing only. Yeah.
Yes.
Does that satisfy the question? But this, definitely it's necessary. Without testing what you have remanufactured, you cannot be sure that this satisfy all the quality. And moreover, before doing additive manufacturing or remanufacturing, you may have to do non-destructive testing of the original product, so that the new after repair it maintains the same quality.
Okay. Yeah.
And commercially available systems are there.
Okay. Yeah. Somebody asked this question. You have talked about use of chips with bamboo sticks and epoxy. In what practical purpose? It can be very good in making the pavements, etc., flooring actually. So because with me that a civil engineer was also working, and we made these type of chips, bamboo sticks, and in between we put chips and epoxy. So it can be used while making the floor. Okay, that is one thing immediately we could think about that. But there can be many other applications, like we can use in furnitures also. So nowadays we are in fact trying to make bamboo wood also in a big way in Assam, because bamboo is too much. Then Abhishek has asked one question: if a teeth or gear is damaged and all other tooth are all right, can we get it corrected by additive manufacturing? Yes, of course, it is. That is the advantage of additive manufacturing. In fact, I have seen some people doing that. If gear is of steel, then it is possible the deposition of steel layer by layer for remanufacturing of damaged gear teeth. Yes, with metallic 3D printing, it is possible. In fact, you may have sometimes very bigger size gears are also repaired like this. And then another person has written non-destructive evaluation. So it is possible to do that. Okay, fine. So all the questions are over, I think now. Yeah. And because other speakers' time is also there. Yeah. So yeah. Yeah. You are muted. Yeah. Khandelwal ji.
Thank
Okay.
you, sir. Yeah.
Yeah.
Thank you, sir.
Yeah.
Thank you, Professor Dixit, for your lecture on design for manufacturing. With detailed steps you have covered for remanufacturing and the challenges which industries and academia, they are facing for the remanufacturing. And it was rightly said, this industry need to play this government need to play an active role, for encouraging this remanufacturing for by bringing more industry friendly laws, policies, or some tax relaxations, for the startups who are going to start, the journey in this field. So once again, sir, I would like to thank you, sir, for this your lecture, sir.
Okay.
So with this, we'll end your lecture, sir. So can you please stop sharing? So
Okay. Yeah. Sure. Yeah. So let me just see that here. Yeah, you are sharing. Stop sharing. Yes. Yeah.
yeah,
Okay.
thank you,
Yeah.
sir.
Fine.
Yeah.
Yes.
So now let us move to our next lecture. So we have with us Dr. Deepa Srinivasan. Welcome, madam. She's a chief engineer from Pratt and Whitney. She's from IC Bangalore. And so, I'd like to, briefly introduce madam before start giving the session to madam. So, it's my indeed privilege to introduce Dr. Srinivasan. She had a PhD in metallurgical engineering from ISC Bangalore. She has over 22 years of experience in the area of gas turbine materials and manufacturing technology. She is the inventor of several new technologies, having over 35 patents, and have developed more than 50 technologies, process applications that are now running in several gas turbines and steam turbines. She has a pioneer in the area of metal 3D manufacturing, 3D painting, or additive manufacturing, and has developed several applications for metal laser additive manufacturing as a unique technology enabler for gas turbine components, repair, and component life extensions. She was recently awarded a certificate of excellence by Government of India Steel Ministry for her pioneering efforts in additive manufacturing. So today she is going to deliver a lecture on application of surface engineering in remanufacturing. Before giving the session to Mena, I'll just stop recording.